If we have a system of particles, we want to see how Newton's law can be expressed in terms of the whole system. Suppose these are a collection of particles, M1, M2, M3, M4. In general, we call Mi. I goes from 1 to whatever number of particles we have, and each one has a force acting on them. F net for 1, we call it just F1. This is net force on M1. For each one, there's a net force. This is F3. It can be in any direction, right? F2, and in general, Fi. And then we can write Newton's law for each one. We can say F1 equals to M1 A1 as a vector. F2 equal to M2 A2, and so forth. And in general, Fi is equal to Mi Ai, right? And so forth until the nth particle. For each one, we can write Newton's law, right? And then if we add all of these equations, what do we get? We get all the forces. Is it okay if I use summation? Fi, I goes from 1 to n. This is all sum of all the forces acting on each one of those. And it's equal to sum of Mi Ai as a vector, right? Is that okay? I goes from 1 to n. I'm adding all these equations together. Does it make sense? All right, so this one is sum of all the forces acting on these particles. We call it net force on the system, F net. But remember that these forces are net forces on these one, but if there's interaction between these particles, whatever force 1 applies to 2, 2 also applies to 1. So if you add all of these forces together, the net forces, the contributions of these action-reactions that are internal forces cancel each other, because for one is one way, for the other one is exact opposite. If you add like vectors, they all cancel each other. The internal forces cancel each other. If you add all of these, the only ones that are left are external forces. So internal parts cancel each other. So I write external here because it's the same thing. If you add them, only external forces remain. And then the other side will be sum of Mi Ai. All right, so this will be the Newton's law for the system of particles. But now we want to have one particular point in the system that is representative of the whole system. And it acts like as if you apply all the external forces to that point, it is like all the mass is at that point and accelerates according to that. I call that center of mass. If I want to do that, then I write F net external equal to total mass of the system times the acceleration of that point, which we now call the center of mass. And now we want to see what this center of mass should be. And m is the total mass of the system. So m is equal to sum of mi. I from 1 to n. It means all masses together as the total mass of capital M. Now, if we have this, and also we have this should be the same. Right? If this side is the same, so this side should be the same. So now we see that m times acceleration of center of mass should be equal to sum of mi ai. Right? Or we can say if you divide by m, acceleration of center of mass should be equal to 1 over m, which is the total mass of the system, times sum of mi ai. Right? And this is a vector formula. And then if you take antiderivative of this, because acceleration is a derivative of velocity, if you take antiderivative, you get the same equation for velocities, right? This is the equation for velocity of center of mass, if we define it like this. And then if we take another antiderivative, we get position of center of mass in any coordinate system. R center of mass equal to 1 over m sum of mi Ri. And then R center of mass has two components. We have x of center of mass I hat plus y center of mass. Now if you do a distribution here, so x of center of mass should be equal to 1 over m sum of mi xi. And y center of mass, and you have z center of mass the same way. So you see, this is formula for center of mass. This is formula for the velocity of center of mass, the acceleration of center of mass, and m is the sum of the masses. And this is Newton's law for the system of particles. If you now know center of mass, acceleration of center of mass times total mass of the system is equal to net external force acting on the system. This is Newton's law for system of particles. Right? Naturally comes from adding all these together and looking at them a little bit differently. Like this is the Earth and Moon some distance away. Let's say Earth has a mass of capital M, Moon has a mass lowercase m. And the distance between them, between center to center, is some distance d. Where is the center of mass of Moon and the Earth? In astronomy, d, the distance between the Moon to Earth, center to center, is 384,000 kilometers. We know the mass of the Earth and mass of the Moon. Actually, the mass of the Earth is equal to 81 times mass of the Moon.
Would we just do x center of mass and y center of mass?
Yes.
Because then you would just do 1 over m plus m, right?
I'm not sure what exactly you're talking about.
So to get the x center of mass, I guess you do 1 over m plus m, like both of them, and then like m times the position that it's at, and then the little m times the position that it's at, and then add them.
Yes, but the thing is, we're talking about x and y. You need to have a coordinate system.
Mm-hmm.
Where is your coordinate system? You see, you have to put a coordinate system on this so that these formulas make sense, mm-hmm. Have meaning, right? So we need to put a coordinate system, and that's up to you, where you want to put the coordinate system. So what is your choice of coordinate system?
I would start the origin in the middle of I'd just start the origin at Earth.
At where? At the center of the Earth? Mm-hmm. Okay, sure. But then which way is the x-axis? Toward the Moon, toward the center of the Moon. Okay, very good. That's the best choice, basically. X-axis like that, y-axis
Just up.
perpendicular to that, right?
Mm-hmm.
So this is y. Yeah, this is your coordinate system. And then you want to calculate all of these, right? So you need to know how many objects are here. How many objects, how many masses do you have? You have 2 masses, right? So this index I goes from 1 to 2. M1 x1 plus M2 x2 and divide by the sum, M1 plus M2, right? So for 2 objects, you have x of center of mass equal to M1 x1 plus M2 x2, that's sum of Mi xi, divided by M1 plus M2. And the same for the y component. So now we have a coordinate system, we have 2 masses, we know what M1 is, we know what M2 is, and now because of coordinate system, we know all the x and y's. So usually we make a table of values. Let's say this is object 1 and 2, we have two objects, right? For each one, we have the mass, and we have x, and we have y, and then we can calculate all of those, right? So let's say the Earth is object number 1, the Moon is object number 2. Right? So for 1, mass is capital M. X of Earth is what?
0.
0. Yeah. Y?
0.
0. For Moon, mass is little m. What is X?
D.
X is D. And Y is
0.
0. So because all y's are 0, we get m1 times y1 plus m2 times y2 becomes 0. Right? So y center of mass is 0. You don't need to calculate. But what is x of center of mass? So x of center of mass is m1, which is m, times x1, which is 0, plus m2, which is m, times x2, which is d, divided by the total mass, m plus m. I guess this was in your mind, so you divide by m1 plus m2. That comes from this formula. Very good. All right, so this term goes away, is 0. So you get m d divided by m plus m. And then if we divide by m, right, divide both numerator and denominator by m. Now if you know the ratio of the two masses, which is m over m is 81, this will be 81 plus 1 will be 82. D divided by 82. And D is that number. So that's 384,000 kilometers divided by 82. How much is that? And that x of center of mass that you get is according to this coordinate system. It shows where it is on this axis. So calculate that for me.
4682.9.
468,
2.
okay, 3
Mhm.
kilometers. Right? You know where that is compared to the Earth? What is the radius of the Earth? Does anybody know? 6,400 kilometers, right? 6,370. This is less than that. Means that the center of mass is actually inside the Earth, right? It is not at the center. That's around here. That's the center of mass. And this is very important because when the sun is applying forces on this system, applies one force on the Earth, another force on the Moon. And there's also force of the Earth on Moon, force of Moon on Earth. Those are action reaction, right? They cancel each other if you add the two equations. Then you get net external force, which is from the sun, is equal to total mass of the Earth and Moon times acceleration of center of mass. Acceleration of this center of mass. Right? Means that that center of mass is actually going around the sun as we say it goes on an ellipse or a circle. Right? And the motion of the two systems can be divided into motion of center of mass plus the motion of all the pieces around the center of mass. If you throw this you see that the center of mass is going on the parabola we were talking about in two-dimensional motion. But then there's motion around that for all different pieces. That is Newton's law for the system of particles. It is net force acting on this from outside is equal to its mass times the acceleration of its center of mass. The center of mass is going on a parabola if there's no air friction. And for the Earth-Moon system, also that happens. Do you know about tides? Tidal?
The moon
Like the-
pulls it or something.
Yes.
Yeah.
You know, if the moon is here and Earth is here and there are ocean waters around, where do we get the high tide?
Probably closest to the center mass.
The closest to the moon, right? We get high tide. Is that the only place we get high tide?
Probably not.
Probably not, because I'm asking that, right? If that is the case, if only this point was high tide, how many tides do you get in 24 hours? Here you get high tide. When do you get another high tide? You go all the way
Next day.
back to here, right? You get one tide per day, but you get 2 tides per day, right? Why do you get 2 tides per day? There's another tide here. There's another high tide on the other side. Isn't that strange? This is the furthest from
Wait,
the
there's
moon.
2 high tides at once on separate.
Yes, why is that?
The sun.
No, it's not. No, if suppose the sun is also the same side. If the sun is also the same side, these two effects add to each other, then you get the highest tide, right? But still, you get 2. Why is that? For now, forget about the sun. It's just the moon. When there's only moon and earth, you get 2 tides. Here, seems natural. Why do we get another tide over there?